Okay, we're a little bit farther up in the sedimentary rocks here. I don't know if we're quite out of this formation, the fountain formation, and into the lions formation, but it's kind of I think they kind of go together. But you can see up here the rocks are a lot less pink. In fact, this little sort of alcove I'm in right here seems to be a lot fresher and maybe eroded out more recently than the more, this stuff. If you look at this, you can kind of see all the lichens. It's very gray and it's kind of hard to see what you're looking at. But if I just move right over here, oh, that's good. Look at that. You can see all the sediments. There's no lichens. There's no real staining or anything. It's much easier to see the geology. This is one of the reasons why geologists will carry around a hammer, so you can freshly break rocks and get a good look at what's actually going on without all the stuff that's growing on the rocks or some of the staining you see, like just oxidation you'll get sometimes if there's a ferric, iron-bearing minerals present. So the grain size hasn't changed a ton, and something I do want to point out is it does kind of ebb and flow. You kind of see some bigger stuff in here, and you kind of see some smaller stuff here. And that's probably due just to rivers migrating or seasonal changes as you go through time. Maybe, if this was just a year or two, maybe it was a little bit more flooding here, and so you got some bigger stuff down here, and versus this stuff up here where it's really kind of fine grain. You weren't carrying as much sediment down. So it usually is due to climate change, or changes in the climate, or simple changes in the weather, or changes in just the rivers and the material that's carrying this stuff. But you should be able to notice, compared to what we saw down there, it's not nearly as pink. It's much lighter colored. And if we look closely, it's mostly all quartz grains. That's why it's a much grayer color. Now there are certainly some feldspar still in here. I can kind of look at this little segment in here, and if we just kind of pause for a second, we can start to see these little pieces of feldspar and all these kind of light pink stuff. But for the most part, it's quartz. It's not very well sorted, right? Like there's all sorts of different sizes in here. You can pretty easily make out the bigger pieces. But there's certainly a lot of smaller pieces in here that you can't quite make out with your naked eye. That's because the sorting isn't quite that good, which tells you again there hasn't been that much transportation from wherever its source was. But certainly this has been transported farther from the granite mountains it came from than the stuff that was down there when we go back in time. So back in time, our nearby mountains were much bigger, much closer. We go in through time, those mountains have eroded down, our coastline is maybe farther out, and you get more quartz. And as we kind of go up through this section, if we were to walk around the way here, I'm not going to, but if we were to walk around the way here and keep kind of going up in the geology, we start jumping up into tens of millions of years later until we actually get to the Morrison Formation, which is a famous formation that has a lot of dinosaur bones in it. Probably the most famous, actually, dinosaur-bearing rock formation. The other one would probably be Hell Creek in Montana, but I digress. So you're getting up into the Jurassic, so you're getting up towards 180 million years ago instead of back down here when we're looking at around 300 million years ago. And I believe this and the stuff above it I think is Permian, so yeah. What is that, 350-ish or so? So yeah, even down there a little bit older than that. Or no, Permian. 252. So we're like 250s in this area, or maybe a little bit older than that, 250 to 300, and that may be around 350 down there. Anyway, so yeah, there that is. Actually, in fact, if we kind of look even farther up here, it gets much more fine-grained. These rocks above me that could fall on my head are pretty standard sort of kind of a medium-grained sandstone. So you can see really coarse stuff, and you get right up above it, and all of a sudden much more of a fine-grained sandstone. So something's going on there where you're not bringing all your heavier stuff down, and you're getting your sand. And reading some of the geologic descriptions of these formations, there is supposed to be some cross-bedding in here, and cross-bedding is evidence of dunes, sand dunes. So think beaches, you're along the coastline and you've got beaches and sand dunes, so that's probably kind of what you're looking at up there, is a 250 280 million year old beach And then if you get in your sailboat and sail that way off to the east, you'll eventually get to another beach. In about, I don't know, 800 miles or so, you'll get to the beaches of northwest Arkansas that were being deposited about the same time period. Kind of cool. So that's kind of it for this. This is kind of the, again, this is the sediment that was being carried off the ancestral Rocky Mountains before these Rocky Mountains were here. And later on they got pushed up again and new mountains formed, and that's what kind of pushed all this stuff up and tilted. So all this stuff would have been flat lying when those ancestral mountains were there. It would have been nice and flat. You know, think about the sediment that's pouring out of the Mississippi River or pouring off the west coast of California or something. And you know, later on you bring up more mountains and bloop, pushes it all up. And we'll talk about dipping rock formations when we get into structural geology and how that all kind of works and what's going on with that. But yeah. So there you go, Rocky Mountain Geology 101. Hope you learned something. I didn't even think about this. These red rocks down here. If you're a fan of concerts and ever come over here to Denver to go to concerts at the Red Rocks Amphitheater, same formation, same thing. So now if any of you guys watching this ever go to a concert there, you'll know something about the rocks that you're walking around on and sitting on. So yeah, that's all. Have a good one. Rock on.